All right, let's talk about something we use every single second of every day. Our phones, our laptops, the computers in our cars, they're literally everywhere. But how many of us actually know how they work? Let's dive in and break down the fundamentals of the modern computer. So, let's just start with the most basic question you can ask. What is a computer? I mean, when you strip away all the fancy apps and the shiny screens, what is it at its core? You probably think you have a good handle on it, but trust me, the answer has changed a lot. The clue is right there in the name. Computer comes from the word compute, which, you guessed it, means to calculate. And yeah, that's what they were originally for. They were just these incredible, lightning-fast machines for crunching numbers, doing math way, way faster than any human ever could. Okay, look at this number. Over 80%. That's a huge chunk of something. What do you think that represents? Well, here's the kicker. If you only define a computer as a calculator, you're totally ignoring over 80% of what it actually does for us today. Think about it. Writing an email, editing a photo, streaming a movie, none of that is just simple calculation. The modern computer is so much more than that. Okay, so if it's not just a calculator, how in the world does it do all this other amazing stuff? It seems super complex, right? Well, here's the secret. It all boils down to a really simple three-step process. And I mean, every computer, from your smartwatch to a massive supercomputer, follows these exact same steps. So here's our modern definition. A computer is simply an electronic device that accepts data, processes it based on some instructions you give it, and then presents the results. That's it. It's actually a beautifully simple idea when you think about it. Let's break that down. Step 1, input. That's you giving the computer some data, say, typing on a keyboard. Step 2, process. This is where the computer takes that data and works on it, following the instructions. And step 3, output. It spits out the result, maybe on your monitor. Input, process, output. That simple cycle is literally the heartbeat of every single computer. And what's really cool is that this three-step process maps perfectly to the physical parts of a computer. So let's pop the hood and take a look at the basic anatomy of a computer system. You've got your input devices. They handle the input step. Then you've got the central processing unit, the CPU. That's the process step. And finally, the output devices. They handle the output. See, it lines up perfectly. Think of input devices as translators. They speak our language, the language of clicks and keystrokes, and convert our actions into electrical signals, a language the computer can actually understand. All right, the CPU. This thing is the brain of the entire operation. Inside, you've got the control unit, which is kind of like the director on a movie set, telling everyone what to do. Then there's the ALU, the arithmetic logic unit. That's the number cruncher, the part that does all the math and logic. And finally, you have memory, which is basically its short-term scratch pad, where it holds on to whatever it's working on right now. And to complete the circle, you have the output devices. They're the translators on the way out. They take the computer's electronic results and turn them back into something we can understand, stuff you can see on a screen, hear from a speaker, or print on a piece of paper. Okay, so we've talked about all the physical bits and pieces you can touch, but that's only half the story. If you really want to get what a computer is, you have to understand the most important concept in all of computing, the difference between hardware and software. And there's this fantastic analogy for it. Think of hardware as the body and software as the soul. The hardware is all the physical stuff you can see and touch. The software, well, that's the invisible set of instructions, the soul, that tells the body what to do. And the differences are pretty night and day, right? Hardware has weight, software doesn't. You can't email your friend a monitor, but you can totally email them a program. And here's a big one. A computer virus can't infect your physical keyboard. It always attacks the software, the instructions. So to put it simply, your keyboard, your motherboard, your RAM, your screen, that's all hardware. But the operating system like Windows, the programs like Microsoft Word or Photoshop, the browser you're using, that's all software. It's the instructions telling the hardware what to do. And you absolutely need both for anything to work. Okay, so now we've got the basic building blocks, hardware plus software. So what? Why does this matter? Well, it matters because that simple combination is what powers, well, pretty much everything in our modern lives. I mean, just look at business. It's impossible to imagine a company today without computers managing payroll, tracking inventory, handling all that massive data. They've completely changed the game. And it's the same story in medicine. Patient records, diagnosing diseases, speeding up research for new cures, computers are at the heart of all of it. It's truly revolutionary. And communication? I mean, come on. Right now, you can send a message or have a video chat with someone on the complete opposite side of the world, instantly. That's all powered by this incredible network of computers. It's not just about data and talking either. We use them to build our world. Engineers use computers to design and simulate everything from skyscrapers to new cars, testing them out digitally before a single physical piece is made. And yeah, even governments run on computers. They're used for everything from analyzing huge amounts of economic data to managing incredibly complex systems, like the entire national defense. So when you really step back and look at it, it's just an unbelievable journey. This thing that started out as a simple calculator, it has become the fundamental engine driving basically all of modern society. And that brings us to the most important question of all. Knowing this stuff, input, process, output, hardware, software, it's not just some boring tech lesson. It's empowering. Because now that we understand the basic language of how these things work, the real question isn't about the computers. It's about us. What are we going to tell them to do next? How will we shape the future with them? That's the question I want to leave you with. Thanks for tuning in.